In this lecture, we will talk about aluminum electrolytic capacitors. We will study the datasheet of an electrolytic capacitor, which is 100 microfarad, 50 volt, 2000 hours at 105 degrees C. Here is the manufacturer number from Rubicon. Here is the capacitor information from Datasheet.com, which gives you a quick glance about this capacitor, including the basic information, specs, and the price. If we go to the datasheet, you can see this is more information about this capacitor. This is a surface mount aluminum electrolytic capacitor. The lifetime is 2000 hours at 105 degrees C. For this series of capacitors, the rated voltage ranges from 6.3 volt all the way up to 50 volt DC. The capacitance tolerance is plus minus 20%. Also, the leakage current dissipation factors are defined here. On the right-hand side, we can see the dimensions for different diameters and sizes. This table includes the multiplier for ripple current. You can see for different capacitance values, there are 4 different frequencies. The rated current for this capacitor has a nominal value at 100 kHz. If the frequency of the current is below 100 kHz, for example 10 kHz, you have to use that multiplier to derate the current ripple for your application. In this particular case, we are looking at 50 volt DC, 100 microfarad. The size is 8 mm by 10.5 mm. The maximum ripple current at 100 kHz is 300 milliamps RMS. The impedance is 0.34 ohm at 100 kHz, which is the test frequency. If you want more detailed information about impedance and ESR over frequency range, you can ask this question to the manufacturer as a special request. This figure demonstrates the impedance curve and ESR curve over frequency range at different temperatures, from minus 25 degrees C all the way up to 105 degrees C. From previous lectures, we understand the basic capacitor model, including the ESR and ESL. So for higher ESR, we can see the impedance kind of flat out at the resonant frequency. In this illustration, we have ESR1, ESR2. ESR1 is larger than ESR2. Around the frequency of resonant frequency, the impedance is dominated by the ESR value. That means if ESR is lower, the performance is better. If you look at the curves, you can notice that as temperature increases, the ESR decreases. Therefore, the impedance also decreases around the resonant frequency. For example, about 20 degrees C, the ESR is found at 0.2 ohm at 100 kHz. Now let's have a comparison between ceramic capacitor and aluminum capacitor. We know these two curves from previous lectures. On the left-hand side, we have the impedance curve and ESR curve for ceramic. On the right-hand side, this is for aluminum electrolytic capacitor. On the left-hand side, the advantage of ceramic is it has lower impedance at higher frequency, for example, over 1 MHz. It has less tolerance, for example, plus minus 10% for X7R capacitor. It is applicable for both AC and DC circuits. The disadvantage is ceramic has lower capacitance and more expensive than aluminum capacitor at the same capacitance. Also, it has the DC bias disadvantage. On the right-hand side, the advantage of aluminum capacitor is it has lower cost at the same capacitance. Usually give you higher capacitance. It can meet higher capacitance requirement. The cons are it has higher tolerance, usually plus minus 20%, and it has large ESR at higher frequency, over 1 MHz. Aluminum capacitor has reduced lifetime at higher temperature, and it is only for DC applications. We showed this picture before, so this is the estimated lifetime of aluminum electrolytic capacitor. The rule of thumb is the life of the capacitor is doubled for every 10 degrees C drop in the temperature. Therefore, The operating condition, such as the temperature, is very critical for the lifetime of aluminum electrolytic capacitor. Recap: we went through the datasheet example of an electrolytic capacitor. The impedance of ESR over frequency are studied. We know the ESR is relatively large for aluminum electrolytic capacitor. If you want this information, you need a special request to the manufacturer. We also did a comparison between ceramic and aluminum capacitors. Thank you and see you next time.